Welcome everyone to this connected conversation on emerging technologies and innovations in renewable energy. Now, renewable energy technologies are really approaching this tipping point, so it's a wonderful moment to have this conversation. What does that tipping point mean? It's really happening in the areas of energy generation, storage, and distribution. And when those come together across so many different areas, they really open up huge opportunities. The opportunities we at UNICEF most care about, obviously the ones that open up a really life-changing changes for children and their communities in some of the most difficult and marginalized places in the world. And these rapid advances and uptake of innovations really hold a promise to potentially leapfrog some of the current infrastructure barriers and really enable what in development we refer to as a just transition. So really a transition in energy that is helpful towards energy equity. And that really will help children and their communities really have incredible changes. And those are just some of the elements we're going to discuss. But of course, the question is, which new and emerging solutions are fit for the future? And that's exactly why we have curated this connected conversation today. So thank you for joining us. My name is Atuya. I'm Senior Advisor on Innovation, and I lead UNICEF's Innovation Nodes. So what are these nodes? They're transdisciplinary and collaborative spaces that focus on reflecting and generating novel wisdom in new and unknown areas of potential innovation for children. And renewable energy and really what's coming out of research in the next 3 to 10 years is just such a case. This really supports UNICEF's global innovation strategy, which seeks to identify gaps and opportunities and uncover those unproven approaches, those emerging technologies that can really make a difference for children and their communities in every country around the world. So joining me today is an incredible panel of experts, Miriam, Amy, and Matus, and I'm going to turn to them and ask them, beginning with you, Miriam, to please introduce yourselves.
Yeah. Hello, everyone. Miriam Atuya. I'm an associate at the CrossBoundary Innovation Lab. My background is in consulting and investment, having spent the last 8 years supporting both the private and public sector in renewable energy and agriculture solutions. A bit about the Innovation Lab. The lab is the R&D arm of CrossBoundary, and our primary objective is to improve the viability of mini-grid business model through testing, revenue generating, and cost reducing innovations. So I'm really excited to be part of this panel and discuss more on renewable energy innovations.
That's fantastic. Thank you so much, Miriam. And you're going to really be bringing this to life literally from the tremendous amount of work that CrossBoundary does on the ground in really the kinds of challenging contexts where we seek to make a difference. Amy, who and why are we making a difference?
Thank you, Atuya. Hi, everybody. I'm Amy Wickham. I'm a program specialist with the Climate, Energy, Environment and Disaster Risk Reduction team here with UNICEF in our headquarters office in New York. Delighted to be part of this discussion and very grateful for you for joining us. Within our team, I lead on the sustainable energy portfolio and just really excited for the conversation we're going to have today. Back to you, Atuya.
Thank you. And Matus.
Hi, everyone. My name is Matus Samel. I'm a principal with the sustainability practice at Economist Impact, which is a research arm of the Economist group, Economist magazine, based in London. But we work with partners around the world to address some of the most pressing challenges. And so we have partnered also with UNICEF recently to discuss and explore the impacts of and the benefits of investment in energy resilience. And I'm really grateful for this opportunity to discuss some of the opportunities, challenges, as well as solutions to the challenges that we're facing. So thank you so much.
Thank you so much, Matus. And I wanted to mention that it's also a fantastic moment in time because there are multiple pieces of research that have just been released, and we're going to be dropping those into the chat throughout. One of those pieces is just come out, has actually been done by Economist Impact. There's another piece of research that's also been done by UNICEF Nodes, and I want to recognize we have energy just transition researcher who was the peer reviewer on that from the Center for Scientific and Industrial Research as one of the participants. I can see Donna Simiyu, so fantastic. Please, we'll be sharing those resources with everyone after this connected conversation, but also want to assure you that we're not just going to parrot back to you what you will be enticed to read, because this is really a conversation that draws forth from some of the implications coming out of those fresh pieces of research. But before we jump in, let's start on a level playing field, because different people are joining this conversation with different sorts of backgrounds and levels of familiarity with the topic of renewable energy innovations. So my first question to the panel is, could you help us to establish a common understanding of how do you see as the key challenge and the key opportunity at hand? And I'm going to turn to this in order. Amy, if you could give us your thoughts first, and then Miriam, and then Matus on first, what do you see as the challenge? And secondly, what do you see as the opportunity? Amy, over to you.
Certainly, yeah, it's a big question, Tanya, and thank you for that. Where sustainable energy is lacking, children suffer, right? Where it's lacking or unreliable, children and young people pay the biggest price, as they're one of the most affected groups due to lack of energy access. And this undermines a huge amount of progress made in ensuring their survival, their growth, and their overall well-being as well. So the challenge is that we need clean and sustainable energy. It's vital for children and young people, as it will improve the quality, accessibility, and reliability of these essential services that they deserve to have access, such as education, healthcare, water sanitation, and hygiene. Affordable, reliable, modern energy, it can also contribute to advancing development goals, reducing poverty, and mitigating emissions that contribute to the climate crisis. So it's really important that we adopt a child rights-based approach to clean, affordable, and sustainable energy access that's no longer, or it's not present in many cases that we're seeing. So that is a huge challenge. And moreover, sustainable energy solutions, they don't only provide essential services, but they also have various benefits, such as creating employment opportunities, assessing international climate funds through carbon credits and emissions trading, generating revenue for local governments and communities, enhancing staff retention and recruitment, but also building resilience during disasters and economic shocks. So, as I mentioned just on the creation of employment opportunities, this also includes for current and future generations, so children and young people. The International Renewable Energy Association, IRENA, which many of you are familiar with, predicts that the sector will create 42 million green jobs globally by 2050. And these sustainable energy solutions can empower girls, young women, increase school attendance, and offer opportunities for them to become energy entrepreneurs. However, as this transition to renewable energy accelerates, we must also address potential risks and adverse impacts on the environment and human rights, including critical mineral extraction, development-induced displacement, and solar panel waste. It's crucial that we proactively manage these impacts and seek innovative ways to manage waste and repurpose materials to close the loop in the material life cycle. So that was just a few of the challenges thus far, Tanya, and I hope I didn't go over time.
Thank you, Amy. And Miriam, what do you sort of see from your perspective of really working with so many communities? And I want to emphasize this at scale.
Yeah, honestly, I couldn't agree any more with Amy. I think the biggest problem is energy access. And from a lab perspective, we focus more on mini grids. So as of last year, there were only 3,000 reported mini grids. And the number that is needed to reach universal electrification rate is 160,000 mini grids. So we are quite far from the target, and it's rightfully so because of certain challenges that have hindered the scale up of mini grids, and these are mostly around business model economics, access to funding, and also the right regulatory framework to scale up the mini grid innovations. So, and as Amy mentioned, the benefits that comes from energy access goes beyond bottom line profitability, number of households, electrified. There's so many non-monetary benefits that we're seeing. And from the lab's perspective, one that we see quite often is when you offer affordable, accessible energy, it frees up most of income that is directed towards high-cost electricity. And what this does is then families are able to access good quality healthcare. They're able to offer good living conditions for their households, and also send a lot of children to school. So one of the feedback that we get from our innovations is the study time increases after the access to electricity. In terms of opportunity, I think amidst all these challenges, there's a great and a large scope to innovate. We are seeing a lot more innovations coming around, and it's such a great time to see this come to light. And some of the interesting innovations that we are seeing is around new technologies that are coming into play into the market. You know, we're but in addition to mini grids, we're seeing the introduction of mesh grids, which are solar home systems that are able to communicate and share information with each other. So if someone needs more power compared to their neighbor, then the technology is able to take note of this, and you're able to share power within households. There's also the use of smart meters, so you're able to monitor the load in your house and be able to pick up the equipment you're using and how much you're using at any given moment. And now we are at a time where we're exploring the use of second life batteries as storage for mini grids, which could significantly reduce the cost of mini grid capex to the developers, and subsequently reduce the cost base and reduce the cost of tariff that is offered to communities. So it's such an interesting time to innovate. And what is also supporting the innovation is we're also seeing a reduction in cost of material for the infrastructure itself. So panel prices are going down, battery prices are also going down, and it's pushing the industry as a whole to reflect and think around the cost of providing energy to households and public facilities.
I'm so glad you mentioned that, Miriam, because it is about desirability and feasibility and viability. And you mentioned a number of really key economic drivers. Matus, you've been doing, of course, from an Economist, a very deep dive into that. Could you tell us a bit more, from that perspective of challenge and opportunity, what do you see?
Yeah, no, absolutely. And I think Amy and Miriam set the scene exactly right. Like in terms of the gap that we see in terms of the access to electricity, to reliable electricity, especially in developing is huge. It's absolutely massive. And that requires significant investment. And what we have seen over the past a couple of decades is actually that around the globe, around the world, we have seen a significant increase, a threefold increase in the investment into renewable energy around the world. But vast majority of that has happened in the rich economies. So we are seeing that developing countries are needing much more investment, especially private sector investment. And we see that there is a sort of 4 times less investment coming into renewable energy in developing countries compared to rich economies. And that gap needs to be filled. Right? The International Energy Agency expects that at least 60% of the funding that is required for renewable energy in developing countries will need to come from private sector. And that's where the problem is, because what we are seeing is that in the emerging markets, developing economies, we see that the vast bulk, the majority of the funding is actually coming from public sector. And that's something that needs to be addressed, right? And we actually have seen that over the last decade. So compared to the early, sort of 2010 decade, we have seen a sharp decline in general private sector investment in developing countries, let alone in terms of private, in terms of green energy and renewable energy. And part of that explanation, or part of the story, is our global forces. So we have seen foreign direct investment declined because of sort of lower returns, rising labor costs, et cetera, including political fractions, geopolitics, supply chains. But part of the story is absolutely in terms of local policies and frameworks and investment climate. And that's what we really want to also highlight, is that it is a difficult job. It is a difficult job to sort of attract investment in particularly these sectors, but generally. And we are seeing a lot of regulatory and fiscal environment challenges that countries face. And these are not easy to fix. These are obviously difficult challenges, but they are fundamental when it comes to attracting especially private sector investment. And secondly, I think it's the point about particularly providing energy resilience to the social sectors, and that comes very clearly from our research, is that when it comes to healthcare, when it comes to water, when it comes to education, a lot of the benefits are sort of down the line, right? And there are not clear revenue streams a lot of the time. And that's something that requires local political will, that requires certainty and clarity about how investors can join the investments, how can they reap the benefits, how they can earn the revenues. And that is a fundamental issue when it comes to energy resilience in the social sectors.
And just on that, it gives me it's a wonderful lead back to Miriam. I wanted to connect some of the things that Matus was mentioning about investments, economic benefits, and opportunities to CrossBoundary's experience. Because I think in scaling the mini grids, you've been looking at business model economics, regulation, and you mentioned earlier sort of investment. And I'm wondering, could you kind of connect to some of this and just talk a little bit to, yes, these are barriers, and they've historically made it quite difficult for mini grids to be established. But you mentioned there's now 3,000 of them. Yes, it's far short of the many more the six figures that we need. But are we making progress in this area of sort of the economic case, the business economics of this? Over to you.
The short answer is we're making progress, but a lot needs to be done. A lot needs to be done for us to electrify everyone and for everyone to consume the minimum energy required on a household level. So if I could expound a bit more on the three barriers that I spoke about and what we've done as a lab and what we've seen as the outcomes through the interventions we've had and the support that we've had from industry stakeholders. So in terms of business model economics, so currently most countries, the national grid is heavily subsidized by the government, which leads to lower electricity cost of about 10 cents dollars. And this subsidized pricing becomes difficult for mini grids to compete on affordability, as their costs are usually extremely high or are often high. So what we've done as a lab is we've worked with a number of developers to see how can we reduce the overall cost of running mini grid operations. And this could be from an OPEX angle and also from a CAPEX angle. From OPEX angle, we've looked at prototypes such as OpEx optimization, where can cost be done in terms of monitoring operations and things like that. From a CapEx angle, we've looked at various new technologies that we can employ at mini-grid sites to reduce the overall CapEx outlay. And one of them that we've looked at is the use of mesh grids. As I mentioned, the mesh grids technology are solar home systems that are placed in households, and they're able to communicate with each other depending on the energy demand on a household level. And from our prototypes, we've seen that the use of mesh grids has reduced the cost of CapEx by around 50%, which is quite significant compared to what we're looking at compared to the centralized grid systems. On the other hand, we've also prototyped innovations that are revenue generating. So looking at how we can increase load and increase revenues for mini-grid developers, which will eventually lead to them reducing the cost of tariff to their clients and their customers. And some of the ways that we've looked at this is we've explored tariff subsidy programs in Sierra Leone, where we reduced tariff by about 40%. And this not only increased consumption, but also we realized that it did not have any effect on the revenues of the developers. So with the tariff subsidy, and something else that we realized with the tariff subsidy is you don't need to offer tariff subsidy for the entirety of the mini-grid operations. You only need to offer it over a short period of time, and then the mini-grid becomes sustainable on its own at that specific tariff. So yes, as a lab, from a business model economics, we have trialed out a few things to see how can we reduce the overall cost down and make energy access affordable to everyone. Most of the publications can be found online. I believe something has been shared at the chat, and you can see some of the publications we've done around the unit economics of mini-grids. On the second aspect, on regulatory framework, so convincing governments that mini-grids are least cost-effective way of electrifying people has also been challenging. As you know, most governments have their own plan of electrification and they've laid it out. But we also know that governments are also constrained at a national level in terms of budget to offer electricity to everyone. So what the lab has done, we worked with the industry associations, mostly Africa Mini-Grid Developers Association, AMDA, whose primary purpose is to improve the political and financial environment for mini-grids in Africa. So with associations like AMDA, the lab works to provide data that offers the compelling evidence that mini-grids do have an economic and social benefits to the communities that we serve. Lastly, on investment, since the lab's inception, yes, Matus funding has decreased over the last 10 years, but we've also seen an insane amount of money directed towards renewable energy on the continent, upwards of about 140 million. And we believe that some of the work that we've done as the lab has provided evidence and helped with unlocking this capital into the sector. So one of the challenging things that has hindered investment in renewable energy is the lack of data showcasing successful business model. So as a lab, we are the largest repository of renewable energy data on the continent, and we use this to draw insights, particularly for the investors, and show them that even with the innovations, even with the likes of tariff subsidy, the mini-grids business model do make sense in terms of returns to investors.
That's fantastic. And I mean, I think it's useful just to place in context that, you know, the continent of Africa as such is the most energy poor, you know, region of the world. And obviously for children, it's really where huge sort of demographically a number of children stand to benefit along with their sort of community. So it's it's really important for the world to be able to actually access the sorts of data that comes from that context. And I want to turn to you, Amy. So we have a perfect positive storm, because sometimes you have good innovations and just sort of pilot money. It doesn't go anywhere. You have sort of some things where there's a lot of interest, but it sort of is scaling in an area that doesn't necessarily benefit the most marginalized or those who really have huge gains to be made across what Miriam was just mentioning, the social and economic and other benefits to society. If we get it right, because it seems like the jigsaw puzzle pieces are sort of there's innovation, technology, financing, business models, data, evidence. What does it mean? What is that opportunity? Can you tell us a bit more?
Yeah, absolutely. Thank you, Tanya. And just building on, what Miriam was saying, and with the child's lens, if we're to consider that parts of sub-Saharan Africa, only a quarter of health centers and a fifth of schools have access to reliable electricity, it's a really huge gap, and there's a fantastic opportunity in terms of addressing this gap by improving, prioritizing clean, affordable energy solutions such as solar powered water and electricity in under-resourced schools and health centers. And that will really help us to bridge this gap and enable that access, especially for children and young people in these critical areas. So yeah, there's a vast opportunity with decentralized sustainable energy solutions. They're becoming increasingly and financially, technically viable, and they enable uninterrupted essential services, power, water, sanitation services, healthcare facilities, and schools. And they also contribute to GHG emissions reductions and pollution reduction, as well as being more resilient than other sectors in the face of disasters or extreme climate events, hazards, shocks, and stresses. So if I think about the opportunity for addressing this gap, and also in a UNICEF capacity, we're present in 190 countries worldwide, and we work closely with communities to enhance service delivery in under-resourced schools, health centers, and communities. And by focusing on the geographically challenging, remote, off-grid communities, as well as those affected by humanitarian and prolonged crisis, our UNICEF's global sustainable energy initiatives aim to reach these most vulnerable children and young people. So I think that's a really big opportunity that we can't we can't shy away from, but also we have a unique advantage when it comes to scaling solutions, and that's to do with our partnering with our procurement of resources. We can influence the market. We also have expertise in supply management when it comes to buying solar panels, along with our extensive presence in health education and WASH facilities. And then we have a special ability to implement and monitor these systems effectively. But all of this is, very much linked and in collaboration with partnership, right? And working with strategic partners, we develop efficient ways to monitor and maintain panels and overall system sustainability. Also, by combining the benefits of multiple energy projects at the same time, we have a potential to reach economies of scale. And this is where Matus comes in, and the fantastic research with The Economist is how we really can reach these economies of scale when we are acting on the ground to implement these sustainable energy solutions, in particular for children and young people. And these all align with UNICEF's global goals of reducing greenhouse gas emissions, advocating for climate action, as well as promoting social equality.
Absolutely. And I mean, just to add to the full range of opportunities and advantages that today's technologies bring, improving social protection. So really, as a women, walking down a completely dark area is less safe than it is if you can go and travel in a lighted area. And that's a sort of a basic security thing that anywhere in the world, from the most to the least developed areas, we know about. So just that simple thing about improving, protection and security for children, women, and every community member is super important. And of course, as we mentioned earlier, green collar jobs. I mean, the kind of jobs that are really not of the future, they're almost the future today on our doorsteps. And sort of, just the incredible economic opportunities that can be unlocked. But speaking of the future, as you can see the picture behind me, that's a young person with a solar panel, which is the format that we have today. But emerging out of research and not too far away are the sorts of solutions that don't mean we need to necessarily stick to panels. There's paint, there's dots, there's glass, there's all sorts of things that are, in terms of generation. There are new ways of energy storage, which are really much more supportive, even more, to distributed energy and also to the systems of managing that distribution. So, not only do we have building blocks that are really positive for today, but, science and research that is generating feasibility, not only scientific, but starting to move into actually business, financial feasibility in terms of how this whole space of renewable energy is moving. And this is something that the Intergovernmental Panel on Climate Change, that's that big global group that meets and kind of provides these huge reports and recommendations into the United Nations and to various governments. And last year, they urged the global community to invest not only in a portfolio that includes the innovations of today, but of across multiple time horizons, because there's simply sort of more efficiencies that will be gained by the technologies that are coming, literally tomorrow, and that what works today may not be as effective in 10 years' time. So let alone, where foresight lives in 25, 50 years. So really in a very, conceivable time frame. And so they've sort of encouraged the global community to continually understand, examine, and look at those emerging renewable energy technologies. And, there is this typical 3 horizons, horizon 1, 2, and 3, incremental, sort of substantive breakthrough technologies, and really spreading your bets, if you will, across all 3. So I want to speak a little bit more about this, and just also to flag to those who have joined us for the Connected Conversation, there are some resources that have been posted in the chat where you can access a whole report that dives into exactly what sorts of technologies are emerging, where they are, what some of their challenges and opportunities are that they unlock. But in general, let's dive into talking a little bit about what it looks like at different horizons. So Miriam, turning to you and at CrossBoundary and your partners are really demonstrating today the potential of innovations at kind of horizon 1 at scale across a huge number of markets. And, could you share with us really what are you finding that is the most promising and impactful, and what are the tactics that work? How does CrossBoundary catalyze uptake of the new solutions when you're kind of introducing something into a market, as you mentioned, mini grids, mesh grids? How do you introduce those concepts when they're new and get the sorts of uptake and then, that momentum? Because certainly as a fellow African, absolutely the last sort of 2.5 years has been a tsunami, a positive one, of renewable energy products and dropping prices into our part of the world. So over to you, Miriam.
Yeah, Tanya. So I think I will start with how we go about prototyping, and then I'll move towards taking them to scale. So the lab success and the process is underpinned by 3 core capabilities. Our prototypes are user-driven. So we take a user-centered design approach in all the prototypes that we do. And it is important that we prioritize the needs of end users. And this can be customers, it could be developers, utilities, or governments. So the way we go about prototyping is we don't take a top-down approach. We don't introduce the prototypes into the communities we work with. Instead, it's the other way around. We work with developers and they bring ideas or challenges where they see, and we work around building prototypes around that. And the reason why this is important is we want to mitigate, project abandonment, cost overruns, and any unnecessary corrections along the way. And this is proven that if you don't do this ahead of time, there's a likelihood that you will. There's a 15% chance that the project is going to be abandoned, and your cost could even be more than 63% of what you had initially anticipated. So that's the first approach into getting to the prototype, identifying a prototype. And then the second aspect is we do rapid iteration with our prototype. We move from launch to scaling quite fast. And the reason why we do this is we want to fail quickly. We want to learn as soon as possible, and then we can converge on solutions that actually make sense. Again, research shows that almost 80% of initiatives end up not working. So as a lab, we want to identify the 20% that will work quite fast. And then these are the ones that now we will move to scale. And then lastly, data. Data is our biggest friend at the lab. So as I mentioned earlier, we hold Africa's largest repository of mini-grid data. We collect data at an interval of 15 minutes. And we have a dedicated in-house data analytics team that help us really sift through this quite quickly, run analyses, figure out what is working and what is not, and we iterate on that quickly. So that's sort of the process that the lab goes through in terms of like prototyping. So for scaling, so typically our prototypes will run between 1 to 2 years, and in between we're doing the iterations. In between we're engaging industry stakeholders, development parties, development agencies, government, lobbying the government as well around regulatory framework. And then so after the 1 to 2 years, we've collected enough data, we're able to analyze and say this works, this doesn't work. For scaling options, typically at the scale-up stage, this is where the private sector comes in. There's a bit of government intervention, but at scale, there's very little involvement of the lab, because our work, at that point, our work would have been done. We would have proven the solution. We would have provided the necessary information that is required. We would have attracted the necessary stakeholders into the country, into the region. So be it private funding, be it development partners, be it technical partners, and the government would have been involved by that. So our goal is to just provide the data, make sure it's working, bring together the various stakeholders, and at scale, most of our projects are able to run by themselves with little involvement from the lab.
It's fantastic. And, I love how you, carved that into, also failing first attempt in learning. I think I love that kind of acronym as well, because it's also important to know why things don't work. Because that really helps us to inform thinking. So why, obviously investing in the things that do, and really there's incredible insights and value from being able to document and have the data on what doesn't. And so Amy, I want to sort of turn to you. And before I do, I want to sort of invite our participants, if you do have questions. We already have someone who's kicked off our first question, and we did receive a number of questions in advance as well, but please, we'll be, after this current round, be opening it up to talk to the questions we've received. So we'd love to sort of have more from you. And I know the one that's in there is talking about financing and how challenging that is. So we will get to talk about that. But Amy, UNICEF is deploying the current energy solutions, as you shared earlier. So could you sort of share a little bit about what does having better visibility on new and emerging solutions in the renewable energy space mean for children? And, how might UNICEF go about further understanding that feasibility, viability, desirability, in a 1 to 2 year time horizon, which is really sort of something that the Innovation Node Insight report that we linked to in the chat talks about. And is there any solution that you're particularly excited about? Over to you.
Perfect. Thank you, Tanya. Yeah, I think, it's very clear for all of us that we know technology and financial innovations are required to change the status quo and to rapidly deploy these reliable, affordable energy systems for future generations, especially children. And having that greater visibility on these new and emerging solutions can support us and can support UNICEF in customizing these energy solutions that we bring to different dynamics, such as disaster response in areas highly impacted by climate change. So for an example, since UNICEF is covering, a breadth of countries and geographies with vastly different energy market dynamics, such as levels of access and affordability of energy technologies, as well as other contexts. We have been carrying out detailed market assessments in different regions to understand the needs, the demands, and the costings around provision of renewable energy within UNICEF priority sectors, such as healthcare, education, water, sanitation, and hygiene. And these market assessments, they're becoming a multi-sectoral data collection activity. I know, Miriam, your the breadth and scope of data that you're engaged is fantastic. And I think there's ways that we can connect in terms of these market assessments and what you've been doing. We've been prioritizing this from a child's lens, and we've started to develop investment cases, and building on the data from these market assessments, we're learning that there's not a one size fits all solution to meet these energy needs. While we're promoting the most sustainable, durable, affordable solutions, we need to consider the geography and the sectoral need. So it's really important that we're staying up to date with new innovations and renewable energy, and it becomes imperative to how we recommend these customized, efficient, affordable solutions. So how we do that? Well, it requires, of course, working with private sector and other cutting edge institutions who can scan the market and source these innovations. And this is where the report comes in, in terms of making those recommendations to keep UNICEF up to date with our feasibility and our viability of these technology solutions, and using these market assessments as well to provide these insights on different market needs, capacities, and desirability, which surely will impact the uptake and the long-term use for children. To the latter part of your question on exciting innovations and what we think going forward, or what I think the integration of new technologies, especially around flexible solar PV and storage, will really ensure long-term use in environments that are constantly being impacted by climate change, including disasters. So as we know, the cost of solar is dropping and below that of fossil fuels for electrification in many cases. And from the Innovation Node, the Insight report that you've mentioned, Tanya, we noticed that the third generation technologies, they're emerging as an even cheaper and easier produce option versus first generation silicon PVs. Examples of third generation PVs can include solar film, solar glass, solar textile, where we see vast opportunities, such as to deploy in humanitarian, post-conflict, or post-recovery reconstruction settings, where flexibility and ease of maneuverability is required. For example, solar textiles used as canopies to electrify shelters in humanitarian crises. But then lastly, innovation around thermal energy storage is also necessary. And I think, the energy capacity required for heating and cooling currently makes renewable energy an expensive and unattainable option for many places. Stored heating solutions, they're important, and they ensure safe and clean drinking water, sanitation processes included. And cooling can ensure that children can have access to necessary healthcare in most remote places. And similarly for school, cooling and heating storage options in school encourages children to stay in school longer, fulfills their education year round, no longer based on seasons, and attracts, quality skills and teachers who want to stay in these schools because they have access to cooling and heating in environments where it's really needed. So our market assessments are showing high demand for these energy solutions and innovations that improve capacity and costing around battery storage, especially in areas of flooding or storms causing low solar irradiation, making battery storage more important to deliver consistent battery supply or power supply. And the consistency and reliability is key. And I think we all agree that, that's key to create this trust in renewable energy so as to become the preferred energy source for children and for their futures.
Oh, that's tremendous. Thank you, Amy. And now, Matus, I feel like we've now talked all the way around to perfectly end in this round with you. You've done so much at Economist Impact with really collaborative market research, and really generated in the report that you've just released with UNICEF a whole range of wisdoms and insights. And we actually have a couple of questions I can tell are from entrepreneurs. So in general, before we get to those, what would you say from the learnings are your recommendations for entrepreneurs, for investors, when you're driving to sort of the take-up of new and emerging renewable energy technologies, really based on the findings of this really fresh research?
Yeah, no, absolutely. Thank you, Tanya. And I think Amy and Miriam have done an amazing job in terms of explaining exactly what we are seeing, in terms of the need for it and the opportunities for innovations, right? And there is so much going on, and the need for local solutions is absolutely great, right? So I think that there is a lot of opportunities there. But from our perspective, one of the important thing that is, like, when you look at the sort of economic benefits, right, beyond the technological solutions that Miriam and Amy absolutely spot on highlighted, from our perspective, there is the importance of including local community and local value chains, right? Because beyond the technological solutions, the durability of particular programs when it comes to, whether it's solar solutions, whether it's storage, etc., it really, really requires local capacity, local ability to participate in those programs, whether it's in terms of supply chains, or whether it comes to, maintenance, et cetera, et cetera. So, and I think that's one important area that we really want to highlight, that both in terms of when we talk about the opportunities, for saving lives, improving educational standards, as Amy said, improving the quality of education and the educational environment when it comes to water. It is beyond that when it comes to the sort of economic benefits of all these investments. The benefits really need to stay local, right? And that is something that we really want to highlight, and that we have seen in our research, that when we have the successful programs that are sustainable, that are durable, they involve a lot of local training, local knowledge development, local capacity development, and local integration of supply chains. And that's something that I think is really, really important in all these programs, all these sort of technological solutions going forward, to ensure the durability of them.
Fantastic. Thank you, Matus. So I'm going to turn now to a number of fantastic questions we have in the chat. I'm going to actually dive into one from Samson. So Samson is asking, he's in the process of initiating a project on green innovations and the circular economy. He's coordinating this and asked us around what initiatives are there in UNICEF. And I would actually broaden this beyond the nodes in terms of biodigesters. I will actually take the first stab at a partial answer to this, because Samson, one of the questions I was asked as kind of UNICEF's lead of the whole innovation nodes was, in this particular report, why did you focus so much on solar as a particular type of renewable energy? So I couldn't have been more delighted to have read the New York Times article recently that was talking about how, solar is just the technology of choice that is around the world in a range of different circumstances, really surging, because that is something that we actually did with a whole range of researchers from across the sort of world, as we looked at things like, for example, I got asked, why did you not spend more time on tidal generated energy? Biodigesters is obviously one sort as well. So UNICEF has had experience in working on pilot biodigester initiatives, particularly actually in schools, because one of the things, this would be when you're feeding biomass of various kinds, and in that case, it was actually trying to have a circular economy of using human waste to eventually generate electricity for cooking school meals. And so there was a lot that we kind of learned from that in terms of, what works and how much input for some and how much output, to put it politely. There really have been a range of pilot level initiatives, but when you're looking sort of at things that we could really go to and support at sort of scale, and I think leverage a lot of where, as Amy was saying, we have our footprints with partners. Our sweeter spot, let's put it that way, has been in the sorts of things that we are investing in, which is a lot that's based on solar. And then that also, when from the nodes perspective, we look at where technology is going, where investments, patenting, research, etc., is pushing, then that kind of addresses, in terms of innovation, the feasibility, viability, etc. It definitely speaks to that being a really strong, sustainable, area. But I'm opening it up to any of the others if there's anything you'd like to add about biodigesters as a format, and then we'll jump into sort of some of the other questions that are really around. I think this is a great financing question. There's one around carbon offsets, our favorite bugbear in this space. But first of all, anyone who wants to add anything on biodigesters? No.
I think just to complement what you've mentioned, Tanya, is that even last year, UNICEF Burundi, we were installing biodigesters, and we did that in 2 hospitals for production of biogas. So just to complement, these initiatives are ongoing, and it's fantastic to see the question raised.
Fantastic. So let me jump into one that I think Matus and Miriam, you will definitely have some good perspectives on, and it's around renewable energy startups. And the question is coming from a Latin America environment, just if that gives us more context, but they're really talking about how do you access funds and support, because and I would just sort of say to the questioner, this frustration that you're feeling, there's free money flowing around Silicon Valley for any old idea, you just stick AI in it and the tap opens. I mean, that's a frustration we see for everything. So you're not, renewable energy is not, unfortunately, unique. But so yes, it is a reality. There is more funding available in other markets. However, the converse, I think, let's ask sort of Miriam and Matus, what do you sort of see in terms of changes, in terms of access to funding in the space, in the developing or emerging economies, which is, of course, what we are most interested in? So, yeah.
Yeah, I'm happy to go first on this. So, well, yes, we're seeing funding go to renewable energy and also some local developers. There's still quite a gap. So actually last year we did a bit of analysis to look into the space and to see where funding is going. And what we realized is that international developers raised 8 times more equity and debt funding compared to local mini-grid developers. And there was a number of factors that led to this. And so we dug deeper into the data, and we wanted to understand where are the gaps, what is lacking. And we realized there was key gaps both from the investor side, but also from the developer's perspective. From the investor side, some of the concerns that were raised were de-risking mechanism. It would have been good if there's a de-risking mechanism to the investments done with the investors, but also being made known of all the innovations and startups in the space. So there's a bit of a gap where investors don't know where to invest, but also startups and the mini-grid developers don't know where to go look for funding. So creating that medium to bring them together was another factor that was brought up. From the developers' angle, one of the things that came up was, so the developers are very tech savvy in terms of like which solutions can we offer, and they dedicate a lot of their resources into that. But also there was a component of bringing, getting funding to bring on board people who can be focused on business development, funding and fundraising, so that, while there's part of the team that is focused on providing energy access, then there's another part of the team that is focused on fundraising. So yes, there's still a gap, but the gaps is not just from developers' perspective, but also the investors raised a key point in terms of like how to de-risk into the sector.
Now, that de-risking piece is really, really key. And I think they're really where all of us can, play a key role, not only being that kind of first financer, but also making sure that we generate the sort of evidence and data that can answer that question for investors. Matus, your perspective from, I'm sure a lot of, evidence that you sort of see in the space, but maybe at a different scale or different perspective?
Yeah, no, absolutely. And I think Miriam was absolutely right that it's a challenging environment, and especially in the couple of recent years where we have seen a lot of also support, direct support in the rich economies, in Europe, in the UK, in the US, for sort of renewable, energy projects, etc., as well as the global macroeconomic environment and monetary incentives. It has made it more difficult to allocate capital into developing countries, and we have seen that. But I think that the positive side is that what we are seeing is that there is more directed effort at a sort of global and international level to established systems that incentivize, or at least standardize systems for investment in renewable green programs, green energy. So I don't think there is enough of that, but when it comes to the sort of financial alliance for net zero, et cetera, we see some progress in there. And I think that more and more of these efforts and programs we see, it will, become more affordable, or become more attractive to provide those investments. But again, at the sort of global level, from the global macroeconomic perspective, there is just not enough done on that, and we see the pressures are very, very high to move capital away. So it's a challenging context, especially these past couple of years.
Yes, indeed. So I'm going to sort of say we've got time for maybe 3 last questions. I'm going to, just because you spoke about a global standard, Matus, going to go to Hannah's question around any thoughts on renewable energy and sort of gold standard carbon offset projects. Any thoughts about that to anyone on the team, on the panel here? And for those who are not sure, the gold standard is the gold standard around. Yeah, Matus, you were coming off. I'm going to pounce on you.
No, sorry. I was just going to say I would really love to hear Amy's and Miriam's thoughts on that. I think that the problem with carbon offsets, as we have seen, is something that we have discussed here, is the data and the reliability and transparency of the actual offsets, of the progress done in terms of carbon reductions and the additionality of them. So to me, from my perspective, from what we have seen, is that with the carbon offsets, having a gold standard, having a standard, global standard, would be extremely beneficial. But so far we have not seen enough progress in terms of the actual implementation of what this could look like, in terms of measurement, especially. I know there's a lot of hope in terms of new technologies to improve the standards, to improve the measurement capacities, but so far it has been very, very challenging, right? So I don't know, Amy and Miriam, if you have a great hope for a gold standard.
Yeah, I think it's a delicate and changing environment that we've seen maybe over the last decade. I was involved in improved cooking programs with UNICEF 9-10 years ago, and seeing how this has all moved now, we see some examples where we have promotion of clean cooking solutions happening in Africa, and they're using technology to certify the CO2 avoided by these improved stoves, using blockchain based on IoT devices. And I think it's exciting for us to stay connected and understand more about these initiatives and what potentials that they can yield, but also to strike the delicate balance where we can deliver programs effectively and not divert attention from the quality programs that we're aiming to deliver towards assessing the CO2 and using the metrics so that we qualify for what may not actually add a huge amount of more value or resources to the program in the first place. So I think it's a case-by-case basis that needs to be weighed very carefully.
And I have to say, I love, I think the intention, especially when you get down to kind of the consumer level intention on, I'm buying an airline ticket and I want to, buy that and pay for that carbon offset. I mean, I think that's exactly the right intention. I think the difference, and Amy, you're right. I mean, this has gone over for decades. And I think now we have so many more instruments actually that are potentially available, sort of innovative financing instruments and ways of accumulating those sorts of funds with the same intentionality and to provide different types of structured finance to do exactly this. Because, the intention is I individually or as an institution want to contribute to, but there's just maybe, now a bigger array. And that is a whole big area of work that we don't have time to hop into. Miriam, I'll give you, would you like to have a last word on this question, or shall we go to a kind of a last one, which is around e-waste, which is of course a really critical one?
No, we can, but before we jump into that, I think the last part of the question was like a route to help financing these projects. And I think you started touching on that, saying there's a huge array of things we could look at. And one of them is especially for renewable energies, the energy attributes credits. So we have all these renewable energy credits that developers or anyone supplying renewable energy could apply, and these can you essentially get money back for proving that whatever you're offering has greater environmental benefits and social benefits than just providing renewable energy, and that can be used to offset some of the cost for mini grids, and this is regulated internationally as well.
Yeah, terrific. And so I'm going to point out, Samuel, you had some questions about how can you partner, volunteer, or get involved with. So I think we'll take that as an invitation for us to share with everyone. We're going to sort of share a follow-up email to make sure we include some resources on that. And so the last question I'm going to ask is Abubakar's one, which is around, we all know this, these technologies are generating e-waste, whether it is in their original creation of the different components and the sort of sometimes the minerals, etc., or in the disposal side of things. And I know that's something that everyone on this panel has been looking at and is quite aware of. Is there any comments we'd like to mention in terms of strategies we have seen to address this e-waste in particular?
I wanted to give the floor to colleagues first, Tanya, but I can come in and share with the group. We have developed, UNICEF's Healthy Environments for Healthy Children has developed key messages on e-waste specifically. If it's helpful, we can put that in the chat. But yeah, over to you.
Yep. Any last points on that? I would sort of say that's definitely in terms of a risk and a risk and a potential negative from this whole area. That's sort of something actually that we deal with in the report itself. So talking about these future technologies, what do they cost in terms of their total life cycle? So I would say, please do read that report as well, because you'll find, a whole lot of resources about that as well. And we'll definitely make the piece available. So unless, Miriam, Matus, unless there are any last thoughts, I'm going to thank everyone for a fantastic panel, really great questions as well from all the people who joined us. This has really been a fantastic connected conversation. It's part of a series that the Innovation Nodes pull together on these new and emerging technologies that are really meaningful, to children, to their communities, and bringing, incredible minds around the table to have a conversation around implications, challenges, opportunities, and, really the brighter future for everyone, especially those in more marginalized and challenged, communities and locations that these new technologies and this new research can really unlock. So thank you, everyone. Thank you to Amy Wickham from UNICEF, to Miriam Atuya from CrossBoundary, and Matus Samel from Economist Impact, and to all of you for joining us. We hope to see you at a future connected conversation. Thank you and goodbye.
Thank you.
Thank you so much, Tanya and everyone. Thank you.